All right, so section 22 is on derivatives of inverse trig functions. So this is the very last type of derivative that we need to know. Oh, is it not up there for you? All right, so the first thing that we're going to do is we're going to review a little bit from pre-calc, which is what an inverse trig function is. So what is inverse sine? What is inverse cosine? So we know that from our knowledge of inverses, right, what we've talked about lately, is that in order to take an inverse, you need something to be one-to-one. Okay? So if you think about what sine looks like, we know that sine starts at 0, 0, goes up, down, back up, and it has a period of 2 pi. Okay? So likewise, it goes back, up, and back down. Okay, in order to take the inverse of sine, we need for sine to be one-to-one. It needs to pass the horizontal line test. Okay, so we can tell right now that it is not passing the horizontal line test. It's going through more than one point at one time. Okay, so we need to restrict the domain. So we have to think about where to make this so only one y value. So for different x values, there's only one y value. Okay, so it's going to be from here to here. So it's going to be from negative pi over 2 to pi over 2. So we basically ignore the rest of the graph. Okay, so that's not the sketch of inverse sine. That's just the sketch of sine. It's restricted. Now, if I was going to do the inverse, remember it's going to be reflected over the line y equals x. So it ends up looking something like that. Okay, kind of weird. Okay, so when I think on the unit circle, if I'm trying to figure out what inverse sine of, negative root 3 over 2 is, what I'm saying is what angle gives me a sine value of negative root 3 over 2. And usually it would be here and here. Okay, multiple places on the unit circle. And then you could add 2 pi and so on. But with inverse sine, you only find the answer on the right half of the circle. Okay. Okay, so it's only going to be on the right side of it, on an arc, right? That's why we call it arc sine. All right, so it's going to be right there, and it's between negative pi over 2 and pi over 2. So I don't call that, I don't say it's 5 pi over 3. What do I call it instead? What angle? Negative pi over 3, right. It's not 5 pi over 3. We have to have it on the interval negative pi over 2 to pi over 2. Does that make sense? That's how arc sine works. And that's why when you do like arc sine on your calculator, inverse sine, you only get one answer, okay? Because there is only one answer. It's restricted to a certain domain. So it says we say inverse sine of x equals y if and only if sine of y is equal to x, and y, which is the angle, is between negative pi over 2 and pi over 2. The cancellation equations for inverse functions are as follows. So you can have inverse sine of x equals x, and you can have sine of inverse sine of x equals x. But the inside one, this is an angle. Your angle has to be between negative pi over 2. And now the inside one, if you're doing inverse sine of something, that's your y value on the unit circle. So the y value has to be between negative 1 and 1 in order to cancel. All right, likewise, if you have cosine, we know cosine starts at 0, 1, and it goes down and then back up, right? And it repeats every 2 pi as well. So again, we need to think about where it is one-to-one. Okay, so we can start here, and we can go down, but where does it stop? Right there, yeah. So it's going to be from 0 to pi is where that one's going to be restricted. So if you think about your unit circle, what part of your unit circle is that? Yeah, the very top, right? So 0 to pi. Okay, so inverse sine is restricted to the right side of the unit circle. Inverse cosine is restricted to the top. Okay, do you guys remember inverse tangent, what it's restricted to? Like one of them. It is the same as sine, right? So the inverse cosine function or arc cosine function is restricted to the domain 0 to pi. All right, so that kind of leads you to some pre-calc questions. Do you guys remember things like this? So why does inverse sine of pi over 4 equal pi over 4, but inverse sine of 7 pi over 4 doesn't equal 7 pi over 4? Yeah.
Negative pi over 2.
Exactly, it's not on that domain. So what I typically did when I was in school is I had to think about it from the inside out. So I had to think about what sine of pi over 4 was. So sine of pi over 4 we know is root 2 over 2. So what we're saying is what angle gives me a sine value of root 2 over 2? But that angle has to be restricted on this domain, on the right side of the unit circle. So root 2 over 2 is going to be right there, which is at pi over 4, right? It's between negative pi over 2 and pi over 2. So we're good. But when you do inverse sine of 7 pi over 4, sine of 7 pi over 4 is going to be negative root 2 over 2. So what we're saying is between negative pi over 2 and pi over 2, what angle gives us negative root 2 over 2 for the sine value? So we don't say 7 pi over 4. I know it's in the same location as 7 pi over 4, but it's not on the domain negative pi over 2 to pi over 2. So what we call it is negative pi over 4. Okay, and even if you did that on your calculator would give you that answer. Okay, it's not going to give you 7 pi over 4. It doesn't just cancel. So don't think that it always cancels. Okay, and same idea for this one. So it's inverse cosine of 7, or of sine of 7 pi over 4. So sine of 7 pi over 4, we just said is negative root 2 over 2. But now we're talking about inverse cosine, so we have to think about the top part of our unit circle. So we're saying, when do we have an angle that gives me a cosine value of negative root 2 over 2? So we're going between 0 and pi. So what would that one be then? Yep, 3 pi over 4, exactly. So 3 pi over 4. All right, so we're going to talk about derivatives of the inverse trig functions. I didn't write out the proof on how to do these. This is like the first year I haven't done that. I'm surprised. So I took it out because it is a little bit hard. But it has to do with the Pythagorean identity, and it has to do with if you let, like, inverse cosine, if you switch, so you say x is equal to cosine of y, and then you do implicit differentiation, and then use the Pythagorean identity, you can get these formulas. So it seems a little bit weird, but you can get them. The ones that you definitely have to memorize are the derivative of inverse sine. So it's 1 over the square root of 1 minus x squared. And the derivative of inverse tangent. So that is 1 over 1 plus x squared. Okay, those are the only two that I've ever seen on the AP test. But it doesn't mean that the other ones wouldn't be on the AP test. They are still things that are on the topics list for things that could be tested, right? So really there's a pattern. If you know inverse sine, look at inverse cosine. See how close they are? What's the difference? It's just a negative. Look at inverse tangent if you know that one. Do you know inverse cotangent then? Yeah, just a negative. And same thing with secant, cosecant. Yeah, they're just negatives. Okay, so really if you memorize not only inverse tangent and inverse sine, if you know inverse secant as well, then you're good. You know every single one of them, right? All right. So it says find the derivatives for numbers 1 through 3. So if you have arctangent of x squared. Okay, arctangent is just another way of writing inverse tangent. Right, same thing. All right, so if I'm taking the derivative, I know that if I'm taking the derivative of inverse tangent of u, I just said on the other page that it's 1 over 1 plus u squared. Okay, that's my formula. So I'm going to have 1 over 1 plus x squared squared. But then I always need to multiply by the derivative of u, the chain rule. So what do I need to multiply by? 2x, exactly. So your answer is going to be 2x over 1 plus x to the fourth. The chain rule. Because it's not like inverse tangent of x, it's inverse tangent of x squared. Right, exactly. All right, so next one. So this one is in the form inverse sine of u, which has a derivative of 1 over the square root of 1 minus u squared, and then times the derivative of u. I'll write it as du. All right, so what do we need here? So it's going to be 1 over the square root of 1 minus the whole 4x is going to be squared times 4. Yep. So it's going to be 4 over the square root of 1 minus 16x squared. That's it. All right, and the next one, again, is inverse tangent. So I'm going to have y prime equals 1 over 1 plus whatever u is squared. So square root of x squared. Do you guys now know the derivative of square root of x? 1 over 2 root x, yeah? So 2 root x. And then I have 1 plus x there. All right, and you could rationalize if you wanted to. All right, does that make sense? So you're really only memorizing 2 formulas for this section. Notice how I say that every section, so it ends up being a whole bunch of formulas you need to memorize. All right, and then the very last one, it says find the absolute max of the function f of x equals inverse sine of x minus 2x on the interval -1 to 1. Okay, so I haven't really talked about absolute maximums of functions on a certain like closed interval, so this is going to be important. So if you have a closed interval, like think about y equals x squared. Y equals x squared, does it have a maximum? It goes up forever, right? But what if we say y equals x squared on the interval -1 to 4? So on the closed interval -1 to 4. Well, what does that graph look like? So if I have y equals x squared on -1 to 4, it's going to look like this, right? And it's going to go up to a height of what? I heard Jack say it, 16. Does that make sense? So the maximum then would be 16. That's the highest that it goes. AJ, you with me? So the highest that one's going to go is going to be to a height of 16. Okay, so if you're on a closed interval, even if it looks like it doesn't have a maximum in general, it does, right? It has a highest point because of the endpoints. Okay, so it says find the absolute max of this function. So we know to find the absolute max, we're going to take the derivative, and we're going to set our derivative equal to 0 and find when it's undefined. So I'm going to have 1 over the square root of 1 minus x squared, and then minus 2. Okay, can you tell where it's undefined right now? X equals 1 and -1, right? So we know that at least. So if I set it equal to 0 and add the 2 over, I continue to solve, so I'm going to multiply the square root of 1 minus x squared over and divide by 2 and square both sides. Okay, when we subtract the 1 over, we get negative x squared equals -3/4. So we have x squared is equal to positive 3/4. Square root, plus or minus. So we get x equals plus or minus the square root of 3 all over 2. Okay, so those are critical values. So usually when you have a closed interval, what you do when you draw your number line is you put the endpoints -1 and 1. Oops, 1. And then you put the other critical values in between. So in this case, if you ever do like square root of 3 over 2, have you guys done that on your calculator? What value do you get? Like, is it decimal?
1.7.
Nope. Close. That's, you're thinking pi over 3. Okay. So square root of 3 over 2, it's going to be, oh, like just square root of 3. Is that what you're saying, 1.7 something? Yeah, so you're going to have divided by 2. So 0.86, right? So somewhere around there. So square root of 3 over 2 is going to be like around 0.866. All right, and then same thing for this one. Okay, so you're going to test in each location. So we usually test in the first derivative to see if things are going up, down, up, whatever they're doing. Okay, so an easy thing to do is if you have your calculator anyway, you can just use your calculator. So you're going to test in the first derivative, which is right here. So let's say I test -0.9. So in this first interval here. Okay, when I test that, I think I already did that. I think I get a positive number. So check it for me. Yeah, so you can put it in for y1 if you want to, if you're going to test a lot. Yeah, Chloe?
What happens to negative x at the top underneath the 3 squared and root 1 minus x squared equals underneath? Do you see how if you subtracted 1?
I don't know what she's saying. If I subtract 1, I get -3/4. Like, is that what you're saying? All right, so I get positive here. I get, I think, negative in the middle, and then positive on the right. So I'm testing in the first derivative. Do you guys get all those values? So you can put it in for y1 if you want to and test. So that means your graph goes up, and then f goes down, and then it goes up again. Okay, so what are my possibilities for the absolute max? There's only 2 places where it could possibly be an absolute max. Negative root 3 over 2, and what else? Yeah, and 1. Because you could have a graph that goes up really high and then down and then not up very much. Or you could have a graph that goes up really high and then up even further, right? We don't know which one's the absolute max, which one's the highest of all those points. Okay, so what we're going to do is we're going to test each of those in the original. So we're going to find f of negative root 3 over 2, and we're going to find f of 1. Okay, so when we find those, f of negative root 3 over 2 ends up being 0.685, and f of 1 is negative 0.429. So when we talk about the absolute max, which one's the highest point? The 0.685, right? That's as high as it goes. So we're going to say absolute max of 0.685 at x equals negative root 3 over 2. Okay. And on the AP test, they actually don't grade that sign chart. They never look at those sign charts that I did, like the little thing. So you would say because f prime is greater than 0 on this interval and f prime is less than 0 on this interval, and blah, blah, blah. Does that make sense? You would have to write out all of those things that you found on the chart. It's very annoying. All right. So are you guys understanding this section? So there's really only 2 formulas that you need to know. So inverse sine and inverse tangent. So what was inverse sine?
1 over square root of 1 minus x squared.
So 1 over the square root of 1 minus x squared. Yep. And then what was inverse tangent? Ah, he's got it down. Do you guys have it down too?
And secant is 1 over x root of x squared.
Yep, good. All right, you got it? All right.
Ask him that one.